Hello, Finxters! This is a tutorial on Pip, which is the official package managing software for Python, and which installs packages from PyPy, the Python package index. If you've ever installed Python packages to your Python environment, then you've most likely run into Pip before. This tutorial aims to be self-contained, so I'll try to describe all the necessary prerequisites to understanding Pip. So why Pip? So as I said, it's the official package manager for PyPy. If you go to their website, you'll see a whole list of packages that are available to you through Pip. And there are a lot of them. There are 336,000 packages as of October 2021. And in comparison to the 7,000 packages available to Conda, that is a lot. So Conda is the alternative to Pip. Easy Install is another alternative. We'll not go into this in depth, but there is an article by Chris which talks about Conda. If you are curious, please take a look at it. So before we go in and start using Pip, I'd like to describe what a virtual environment is. So a virtual environment is an isolated Python environment used for Python projects. And it prevents package requirements from getting broken by always running project in the same environments. So what do we mean by this? So suppose that you have a project that you made today using NumPy and several other packages. And your project depends on the specific versions of the packages that you used today. Now, let's say 5 years down the line, you wanted to, for whatever reason, you need to run the project again. And okay, you open up your computer and you try to run it, but since you've updated your packages from now until 5 years later, because new versions of packages keep on coming out, your project doesn't run because the package dependencies are not satisfied. So in order to solve problems like this, you have virtual environments. So what you do is you download your packages to a virtual environment. And by doing that, you'll have specific versions of the packages necessary for your project right there in the virtual environment. So whenever you need to run your project again, you just have to go to the virtual environment and run it there. And you can have multiple virtual environments on your device. So, one virtual environment have one version of NumPy, the other one might have other versions, etc. Things like, and you can do things like that. Okay, so let's jump into the coding. So before I get started with Pip, I'm just going to have to activate my virtual environment. And since I'm a Conda user, I use the Conda command here, and I've activated the test venv virtual environment. I use this environment instead of running pip in base because I don't want to mess up my usual Python environment. Okay, so let's first check how to let's look at how to list all the packages that are installed in this environment. So for that, I use pip3 list or Python 3-m pip list. In this tutorial, I'll try to stick with the pip3 command because that's much easier to write. So if I run this, I get this list of packages that are already installed in this environment. And just to show you that this result does depend on this virtual environment, I'm going to run conda activate user default. Okay, so now I'm in a different virtual environment. Pip3 list. And then I get this long list of packages. And you can just see here that that this virtual environment has a different set of packages installed compared to this virtual environment. I just wanted to demonstrate, show this in order to demonstrate that virtual environments are isolated Python environments, and that what happens here has nothing to do with what happens here. And you can have different versions of NumPy installed in this environment versus this environment, etc. Okay. So now let's look at how to install packages using Pip. So suppose that you wanted to install, say, SymPy using Pip. Then the syntax for that is pip3 install SymPy, and you run it. And this takes a moment. And you see here SymPy-1.9 blah blah blah. This is called a wheel file .whl. These files are what's usually used to install Python packages. We'll discuss this more later when we get to the wheel command. And this long name here is usually descriptive. So it means that this is the wheel file for SymPy version 1.9, for Python version 3, and then none means there's no constraints on like the platform. So there are different wheel files between, Windows and Mac OS and Linux and things like that. And now, okay, we've successfully installed SymPy, so let's confirm that using list. Okay, and we see SymPy here. We didn't have SymPy before, and now we have it here. So yeah, we've successfully installed SymPy in our virtual environment. In order to uninstall a package, we use the uninstall command. So pip3 uninstall. If we wanted to uninstall SymPy, we put SymPy here. We run it. And okay, proceed yes or no. Okay, and the default value is yes, so I can just hit enter. Okay, and successfully uninstall SymPy. Let's confirm this. So pip3 list. And you don't see SymPy here, so we've successfully uninstalled SymPy from this virtual environment. Okay, so, and I'd also like to mention that if you wanted to uninstall multiple packages at the same time, you can list them like this. So if you wanted to uninstall both NumPy and T, you can do NumPy and then T like this, and then you can hit enter, and then okay, proceed, and then so we've successfully uninstalled T and NumPy, which we can confirm by using the list command again, and we don't see NumPy or T, so we've successfully uninstalled both of them. Now, something I'd like to discuss now is package dependencies. So what are package dependencies? Well, they are the packages necessary for a package to run properly. So what does this mean? So if you have a package like the Django, you need various packages like askgraph, backports.zone.info, SQL parse. So you need these packages in order for Django to run properly in this virtual environment. And the command I just ran, pip3 show, is one way to see these package dependencies. I mean, it also shows all these other stuff concerning the Django command. So it's pretty useful. And in order to so this package dependency stuff is very important because, if you have a Python project and if you're using a bunch of different packages, you're gonna have a lot of dependencies because and it's gonna get complicated very quickly. So one of the things that Pip does is for you to is for it to manage the package dependencies for you. So in order to see broken package dependencies, that is to say, find packages that are required by other packages, you can use the pip3 check. And if you run this, so it says that I have a lot of these packages that are not installed. Requires, okay, which is not installed, etc. So I will need to install these guys for virtual env and Django to run properly. Okay, so that's something you can do. And one way that people manage package dependencies, especially if you're the one developing the packages, you'll want your users to know which packages are required for your packages to run correctly. So to manage that, there are things called requirement files. So for instance, if we go to PyPy and we pick, I don't know, this guy, Rascal, and then it goes to the repository, you'll find this requirements.txt file. So if we open this, what it is it's just a list of names of Python packages. And what this says is that these packages are required for Rascal to run correctly. And the nice thing about pip is it has a shorthand for installing all these packages. So, okay, we have a requirements.txt file here, and I have these files, these packages inside requirements.txt. Notice here that these requirements.txt allows you to specify the versions of the packages that you want to install. So if I run this whole file, it's going to take a long time. So in the interest of time, I'm just going to install just like these two. So easyib and numpy. And how you install from using this requirements.txt file, what you do is, well, you have to first copy the file location, okay, and you use the terminal command cd, so change directory, and then I just copy and pasted the location of the requirements.txt file, so which happens to be here. Okay, I run it, and now you see here that the terminal is directed to desktop where the requirements.txt file is located. And what I now do is run pip3 install -r, r for requirements, and then the file name is, just make sure I don't misspell it, it's requirements.txt, and I run it. And okay, so it just installed numpy and easyib. Easyib version 0.22, right here, and numpy 1.214 as specified in the requirements file. Now if I check the list command again, we see, yep, so numpy version 1.214, and then easyib is here. So using the install command with the requirements file did indeed install these two files. Okay, and there's also a way of outputting this list in a requirements.txt requirements file compatible format. Meaning, so if I just tried, so suppose that, I wanted to make a new virtual environment for a new project that I'm working on, and you wanted to you wanted the new environment to have the same packages installed as test.venv. And how do you do that? Well, you can make the new virtual environment, and one thing you can do is you can run pip install and requirements with these files inside the requirements file. But of course, if you try copying this, okay, if I do this, and if I run it, so R requirements, you're going to have a syntax error like so. So my point is, this column format is incompatible with requirements file format. So we need to do something about this. And fortunately, Pip has a way of coping with situations like this. So the command for that is pip freeze. So freeze is like the pip name for these formats, for formats compatible with requirement files. So what you want to do is, okay, well, let's try running this command first. So you do this, and then it outputs this. And you notice that this is the same format that we saw before when I specified versions of files in the requirement file. So you could just copy and paste this into the requirements file like so, or you also have a way of storing this inside here from the command line. So you can do pip3 freeze, and then you can do this greater than mark, and then requirements.txt. Okay, and voila. So this has been stored in the requirement file from the command line. Okay, let's now move on to distribution files. So let's first look at what distribution files are. So they're the files for installing Python packages in your environment. And there are two types of them. There are wheels and tarballs. So we've already seen wheels in this tutorial. It's just a .whl file that we saw when we installed SymPy. Tarballs are just the .tar.gz files. And Pip prefers wheels because they are faster and generally easier to work with. We will not go into extensive discussion on differences between the two file formats, but just know that wheels are generally more common, and that, you know, if they're available, you would like to use it. Sometimes tarballs are the only ones that are available, so you have to use that sometimes. There are also things called eggs, but they have been deprecated some time ago. Their names do appear in error messages from time to time. Okay, so why distribution files? So distribution files, so as I said, you need to use wheel files to install Python packages, and Pip keeps a cache of wheel files for the packages that you've installed in your environment. So you can use Pip to manipulate wheel files. So one of the things you can do, so where do you get wheel files? So one thing you can do is, well, the obvious thing is you can go to the PyPy website, and if you look at, what could be any of these. So if you look at, say, like standalone here, and if you go to download files, okay, you see here that this particular package only has tarballs. So once in a while you have packages like that, but then if you go to, say, this guy, okay, this guy has both wheels and tarballs. So what you can do is you can just download the wheels and then use that to install your package. So that's something you can do. Another thing you can do is you can do all of this using Pip. So if you wanted to download the wheel file for Django LGI version 0.1.2, then you can use the Pip download command and hit enter. Okay. So it's downloaded all the wheel files. Okay. So you might want to download wheel files like this if you wanted to. Well, maybe you want to install files when you're offline, or you might want to you want to make an archive of these wheel files for whatever reason. And the download command supports many of the options available to the install command as well, so that's nice to know. And another command that is very similar to the download command is the wheel command. So what does this do? So the wheel command, the wheel command builds the wheels. So by this I mean, well, let's just try running it first. So if we wanted to build the wheel for NumPy, okay, so it's running. Okay, so this is the wheel for NumPy, and since NumPy does not have any dependencies, this is the only wheel file we'll get. And the difference between okay, first of all, what do we mean by build? So Python packages are built from like the source code, and if you run wheel files, well, what are wheel files? Wheel files are essentially zip files that contain the content, the files needed for a particular Python package. So if you build or if you install a package using a wheel file, then you don't have to build your Python packages from scratch, versus if you use tarballs, then you do have to do that. So when you run the wheel command on pip, what you do is you build the wheel files using the files from PyPy, versus when you run the download command, you download the wheel files themselves from the PyPy repository. So so in summary, the end products you get from download and the wheel commands are the same, but the processes are different. And there are options to, for the download command, there are options to, modify like the download process, versus for the wheel command, there are commands for modifying like the build process for building the wheel. So that's what those two commands do. Let's now move on to the cache for the wheel. So as I said before, pip keeps a cache of all the wheel files that it's used for building packages. And where is the cache located? Well, to find that out, you can use the cache command with the dir option for directory. And if you use that, okay, so in my case, it's located in this address. So if I use the terminal command open with this address, then, okay, so this is the folder in my file manager. Okay, so this is where the cache is located. And if we want to know more about the cache, we can use the cache info option. Okay, so we see here that so the cache location is here. That's the same address as in the oh, well, no, it's not the same address. This is where the index pages are located. So it's this HTTP file. It lists the size and how many files there are. It also shows you where the wheels are located. So the wheels are located in here, and the number of wheels are 2. And this is how much that's taking up in the memory. Okay, so let's list up the wheels in the cache. So to do that, you use the cache command with the list option, and you cache, and then use the list option. Okay, and so these are the 2 wheel files that are inside the wheels folder. And if we wanted to remove, and these are the wheel files for the SynPy from the SymPy installation. So if we wanted to remove these, we can do pip3 cache remove SymPy. Okay. So one file was removed. Let's look at what was removed. So if we do list again. Okay, so we just ran the pip cache remove SymPy. Okay, so before there was both the SymPy and np math in the cache, and now it's only np math. So what the remove command did was it removed the wheel file corresponding to SymPy from the cache. Now, if you wanted to clear out the cache entirely, then you can do pip cache and purge. Okay, and then this also removes the files in the HTTP folder. So then if we now look at cache info, we should have nothing in there. Right, so number of HTTP files are 0, and the number of wheels files are also 0. So that's what the cache command is. Now, finally, let's look at the pip hash command. So one of the problems with working with PyPy is that, well, essentially anybody can upload Python packages onto PyPy. So in particular, tampering of files is always an issue. So in principle, somebody can upload a tampered Python file onto PyPy, and you might download it unknowingly. So to prevent problems like this, there is the hash command in pip, which generates a hash code for a particular wheel file. So for instance, if you wanted to look at the hash code for this Django LGI wheel file, then you can do this, and then, okay, and this is the hash code. So, and if we wanted to make sure that this Django file on my desktop is the exact same file as on the on PyPy, you can compare with the hash code available on the PyPy webpage. So if we view, and we can, and I think the default, yeah, so this is the hash SHA-256 algorithm. That's the algorithm used to generate this hash code. Okay, so if we compare this hash code 8274A, 117E0D, etc., etc., so this seems to be the same as this this hash code. So this suggests that this Django file, the Django wheel file I have on my desktop, is the exact same file that they have on the PyPy webpage, and this ensures that there hasn't been any tampering. Yeah, this file on my desktop has not been tampered. And there are other options for the hash algorithm. I mean, there's the SHA-256, SHA-384, and SHA-512. Those are the options for generating the hash code. It's also worth remarking that hash codes are not just a pip thing. I mean, it's used all over the web. I mean, it's used in like cryptocurrency, for instance. So it's part of like the general, infrastructure, like security infrastructure on the web. So we'll look at a few more commands that are discussed in the pip documentation. So the first one we'll look at is the Pip Config Command. To understand this, we'll first need to understand what the configuration file is. So the configuration file is the file that that users can use to set the default behavior for various commands in pip. So for instance, you might want to have the list command have output its results in freeze format instead of in the column format. And users can modify the configuration file to get this behavior. So where is the configuration file? Well, the configuration file is always in the form, has the name pip.conf, so we can use the locate command for terminal to find where it is. Okay, so this is where they are. And the locations for configuration files are fairly standardized. So if we go to the pip documentation, we see that for Mac, the global configuration file is always located in this location. For user, it's here. And then for site, meaning for virtual environments, it's like this. So we see that this first one is my global configuration file, meaning it determines the behavior of pip for all users on my device. And the second one determines the behavior for this specific user. Okay, so let's try opening one of them. So if we use the open terminal command, then okay, so this is my user configuration file. And then if we want to open the global one, okay, open like this. Oh, I got the error. That's because I didn't escape the space character here. And then here we go. So this is the global configuration file. Okay, so let's try fiddling around with this. So right here, what this does is, what this says is, when you call the list function, list command in pip, then for the format option, set it equal to freeze. Similarly, if you call the install command, use the ignore installed option and the no dependencies option. So let's see this in action. So if we call pip list like so, then the output is in the freeze format as instructed in the user configuration file here. Now if we delete this, save it, and then run list again, then we actually get the result in column format, which is the default behavior for list. Okay, so now let's now look at what the pip config function can do. So the point of the config function is that we can interact with the configuration file from terminal. So if we, for instance, wanted to look at the contents of the user configuration file, we can use the user option, and then we can use the list sub command. So if we run this, then we have install ignore installed equals true, install no dependencies equals yes, and list.format equals freeze, which is what we had in the user configuration file, like so. If we wanted to look at what is happening in the global configuration file, then we can run this, and then we have install.user equals true. So the install command has a user option equals to true, like so. Okay, we can do other things. So if we wanted to open the configuration file from the command line, we can do config, and if we wanted to use a user configuration file, we can do that, and then we can use the edit subcommand. And if we hit enter, your the user configuration file gets opened in the default text editor, like so. In my case, my editor environment variable is set equals sublime text, so the configuration file opens up in sublime text like this. Okay, so then let's now look at suppose now that you wanted to read off the individual entries from the configuration file. So for instance, so you run, Pip List, and then you notice that it's in freeze. So okay, so you notice that the list command gives the output in freeze format. So you wanted to see whether the behavior is given by the user or the global configuration files. So to check that, you can do pip config, and you can first check the user, and then get, and then you have to look at the name of the variable. So in this case, it's the list command, and if you want to look at the freeze, the format option. Okay. So you read this off, and it's set to freeze like this. So this suggests that in the user configuration file, the list command has format equal to freeze. Now, if you wanted to, let's say, undo this from terminal, you can do pip config user unset and then list.format. Okay. And now, so what this does is that it unsets the list.format variable, meaning that list now has the default behavior for format. So let's try running list again. So as expected, list now outputs it's now outputted in column format, which is its default behavior. If we want to now set it back to freeze, then we can do pip config user, and then we can do set list.format equal to freeze. Okay, and notice that this is the location of the user configuration file from before. Now, just to confirm that pip did what we wanted it to do, we can run the list command again, and then indeed the output is in freeze format. Okay. Finally, if you wanted to look at the content of all the configuration files at once, then you can use the pip config debug command, and then it lists everything like this. So it lists where it is. It lists where each of the files are, and it also lists the values like so. So if you wanted, if your commands are behaving in a weird way, if you wanted to debug them, then you can use this command. I think that's enough for the pip config command. So let's move on to the other two commands. So the next command is the pip debug command, which just outputs a bunch of information about pip that might be useful for debugging. There isn't much to say here. I mean, it outputs like the version and various things about the system, etc. I mean, when you're starting out, I don't think you would really need to use this. And finally, there's the Pip Search Command, which has been deprecated. So if you want to try using it, so if you want to look for NumPy in PyPy, then you can do that, but then you'll get this error message saying that it's been disabled. And as of March 2021, it's been permanently disabled, so you can't use that. So yeah, that's just a command listed in the documentation that's been permanently deprecated. So I guess I guess we're done. We've gone over all the commands listed in the documentation. And I hope you've learned something from this tutorial, and I'll see you guys next time.